Now, in this video, we are going to talk about some special features of dimensions. Now, suppose in any formula, let's say in a formula like L plus alpha. Suppose in any formula L plus alpha, where L is length, and we don't know the quantity alpha. Now, if I say find the dimension of alpha, now as length can be added only with a length, so alpha should also be a kind of length. For example, if I have 2 centimeter plus 3 meter, I cannot add these two together like this. Why? Because they don't have the same units. But if I have 2 centimeter plus 3 centimeter, I can add it together because they have the same units, and my result will be 5 centimeter. So now this is the same concept you want to use here. That is, before you can add any quantity together, they must have the same units. Just like I said, 2 centimeter plus 3 centimeter. Before I can add these two together, these two quantities, they must have the same units to get 5 centimeter. That means if it is 2 centimeter plus 3 meter, they don't have the same units, so I cannot add it together. So follow that concept now, so you will understand this better. So length can only be added to length. That means if L is a length, it is for sure that alpha must also be a kind of length. That's the meaning. So that means dimension of alpha will be equal to dimension of length. So before any two quantities can be added together, then they must have the same units. That means the the same dimension. So that means the dimension of length will be the same as the dimension of alpha. So that is one feature. So you need to understand this feature. So now, because we will still solve example, so now that means in this case, dimension of alpha is equal to dimension of length direct. That is it. Now let's say if we consider another one, let's say we have f minus beta. Now if f is force, what is the dimension of beta? So if f is force, what's the dimension of beta? Now for s should be a force, that means beta 2 must also be a force before you can add it together. For example, if I have 2 Newton, before I can add to another one, that one too must be in Newton. 2 Newton plus 2 Newton should give me 5 Newton. That means if this one is a kind of force, this one also must be a kind of force. And if it is minus 3 Newton minus 2 Newton, for us to subtract again, this must be the same units. That means in addition or subtraction of quantities, they must have the same dimension before you can conclude that is the same. Now if f is a force, then beta 2 must be a kind of force. That is, they must have the same dimension. So in this case, the dimension of alpha and the dimension of beta will also be the dimension of force. Since f is force, That means it must be minus another force, so it can't be different from force. So it is only force and another force that you can subtract or add to get another force, like a third force. So now if I split it, that means F minus beta. So that means beta, if F is a kind of force, then beta 2 must be a kind of force. So, and we have already said that dimension of beta is equals to dimension of force. Now we have done the dimension of force since. So what is the dimension of force? So that will be mass times acceleration. So force is mass times acceleration, and we already know that mass is m and acceleration is lt raised to power minus 2. That means in this case the dimension of beta is equals to ml t raised to power minus 2. Why? Because before we can subtract two quantities, they must have the same dimension. Before we can add two quantities, they must have the same dimension. So now if I have a plus v, now if v is velocity, that means a also must be a kind of velocity. That means it must be equal before we can add it together. That is the concept we are using here. So in any question, you need to, if you know one quantity and you are adding it to another quantity, then you should know they must have the same dimension. That's why dimension of alpha here is equals to dimension of length. Dimension of beta here is equals to dimension of force, whether you are adding or you are subtracting. Take notes of that point. Now let's see example to illustrate this figure. So let's see an example to illustrate this figure. So look at the question. Given that alpha divided by t square is equals to fv plus beta divided by s square. Find the dimensional formula for alpha and beta. That means we want to find dimensional formula for alpha and beta. So how can we go about it in this question? So now where t is time, f is force, v is velocity, and x is distance. Now let's solve the problem. So to find dimensional formula for alpha and beta, let me clear this part. Now based on the first figure, so we're going to form rule for that. So take notes, rule number 1, so you can easily know the figures. So rule number 1, one quantity can be added slash subtracted with a similar quantity only and give rise to a similar quantity. So we can take that as illustration, rule 1, based on what I've explained before. That is, one quantity like 2 centimeter can be added slash subtracted with a similar quantity, let's say 3 centimeter, and give rise to a similar quantity. We can only have 5 centimeter and here 1 centimeter, meaning I can only have centimeter. If I add it, my result will also be in centimeter. One quantity centimeter can be added slash subtracted with a similar quantity centimeter and give rise to a similar quantity centimeter. It cannot change. That is, 2 centimeter plus 3 centimeter can never give you 5 meter. Now this is centimeter, this is centimeter, similar quantity. Now you can't get different quantity. You will either have another similar quantity. That's the meaning of the rule number 1. So now let us proceed with the question. That means in this question, to find alpha and beta, it is for sure if I consider this part, f plus beta divided by s squared. So if I consider that part, that means I will have fv plus this must have the same quantity based on our definition. That is, before you can add two quantities together like this, now I'm adding fv plus beta over s squared. Before I can add it together, they must have the same dimension. That means in this question now, we are trying to say, based on the first rule, that means the dimension of fv should be equal to the dimension of beta over s squared. That's what we are trying to say according to rule number 1. Before you can add two quantities together, they must have the same units or the same dimension. That means dimension of fv should be equal to dimension of beta over s squared. I believe you should understand that. Now, what is fv? We have seen it in the question that f is force is mentioned and v is velocity. Now if we do the two, what is fv now? If f is a force, the dimension of force is ml t raised to power minus 2. So you should know the dimension of force often by now from the first video on dimension. So now fv is equal to ml t raised to power minus 2 times v lt raised to power minus 1, because v is velocity is given. Dimension of velocity is lt raised to power minus 1. F is a force. Dimension of force is this. So if you combine the two, so that means fv now is ml squared, because the power here is 1. Add it together, t raised to power minus 3. That is minus 2 minus 1. That will give you minus 3. That means the dimension of fv is this. Now if dimension of fv is ml squared t raised to power minus 3, that means this is the same thing as fv. You know that the dimension is ml squared t raised to power minus 3. That means if you add it to another quantity, b over s squared, the dimension of this one also must also be ml squared t raised to power minus 3 for you to be able to add it together. They must have the same dimension. Then it is clear now that dimension of beta over s squared now is also ml squared t raised to power minus 3. So that's it. So dimension of fv will be equal to dimension of this. And since we have known fv to be ml squared t raised to power minus 3, then the dimension of beta over s squared is also ml squared t raised to power minus 3, because we are adding the two together. Now from here we can cross multiply, so that, let me make it clear, b over s squared is equals to ml squared t raised to power minus 3 over 1. So you now cross multiply. So if you cross multiply, beta is equals to ml squared t raised to power minus 3 times x squared. You know we are cross multiplying. So beta times 1 will be equals to s squared times this. So that means an x is given, that s is distance if you check the question. Since s is distance, that means this will be a kind of length. So we are going to have beta is equals to ml square t raised to power minus 3 times l square, because s is a kind of length, so that will be l square. Now dimension of beta will be equals to ml raised to power 4 t raised to power minus 3. So how do we get that? That means L square times another L square. In law of indices, you are going to add the power. L square times L square. That will be L raised to power 2 plus 2. L raised to power 4. So that means the dimension of beta is ml raised to power 4 c raised to power minus 3, in which this m can carry power 1. So that's it. So that means beta is this. We have solved for beta. On what condition? Because this and this, before you can add it, the dimension of this must be equal to the dimension of this. Now how can we find alpha in that sense? So let's find alpha. So to find alpha, now if I say 2 centimeter plus 3 centimeter, my results must also be in centimeter. So 2 centimeter plus 3 centimeter must also give me 5 centimeter, meaning I can say 2 plus 3 centimeter is common, so my results must also be in centimeter. That means if I add these two together and I know the dimension of these two, that means the dimension of these two quantities must give me the same dimension of this one, the dimension for the next one. So now let me show it for better understanding. Now we have shown that, look at alpha over t square. We have shown that dimension of fv is what is only fv. Dimension of fv is, if you recall, that will be ml square t raised to power minus 3. Now also dimension of beta over s square should also be the same as the dimension of fv. That will be ml square t raised to power minus 3. But don't forget, the first part we found is dimension of beta, not only beta, not beta over s square. Take note, beta over s square we have this dimension, but only beta is the one that we found. Then that means for these two to be the same, dimension of fv must be equal to dimension of beta over s square. So that means if the two dimensions are equal, that means fv plus beta over s square, we have the dimension of what? ml square t raised to power minus 3. This is alpha over t square. That means we have already said if two quantities are added together, they must give rise to another quantity which is the same as the meter. That means this will be the result of these two. If you add these two together, this is the result. That means as the dimension of these two quantities is this, the dimension of the result also will be this. So that is it. So that means for our question now, dimension of alpha over t square should be equal to dimension of fv plus beta over s square. So like that. And what is dimension of fv plus beta over s square? The dimension is ml square t raised to power minus 3, which is this. So that means alpha over t square should be equal to ml square t raised to power minus 3 over 1. So that means dimension of this is equal to dimension of all this. So that means we cross multiply. So if you cross multiply alpha times 1 alpha, so this will be ml square t raised to power minus 3 times t square. Now t is time, is also given. That means this will be ml square t raised to power minus 3 times t square, because time, the dimension is t. So that means we now have dimension of alpha equals ml square. Now t raised to power minus 3 plus 2, that will be minus 1. So we have t raised to power minus 3 times t raised to power 2. Since t are equal, from law of indices, minus 3 plus 2 will be minus 1. So that means the dimension of alpha is equals to ml square t raised to power minus 3 minus 1. That means alpha will have one dimension in m, two dimension in length, and minus one dimension in time. So we have solved that question. We have found alpha and beta. Now let's see another example. You can backward the video for better understanding. So now another example. Example 2. For n moles of gas, Van der Waals equation is P minus A over V square brackets V minus B close bracket is equal to nRT. Find the dimensions of A and B. So we want to find the dimension of A, and B. Now where V is volume, T is temperature, and P is pressure. So it's given here. P is gas pressure, V is volume of gas, and T is temperature of gas. So everything is given. Now let's solve. So let me clear. So can go back to it. So in this case, how can we find A and how can we find B? It's very easy. Consider this first bracket. Also consider this bracket. You will see now that before you can, if I consider this bracket, that is V minus B, not the two brackets at the same time. This is times, this is multiplication. It's possible to multiply two quantities together. 2 centimeter times 3 meter. At once, I'll get 6 centimeter meter, as in if I multiply. But in addition is not possible, or subtraction. So but I'm not considering the 2 because I don't know the dimension of A and I don't know the dimension of B. So now I want to consider this first bracket. In the first bracket we have V minus B. Now before we can have V minus B, that means they must have the same dimension. Before we can have B minus V, they must have the same dimension based on our rule. That means the dimension of B should be the same as the dimension of V. That is, the dimension of this must be equal to this before we can subtract. The same thing happens to addition. So consider the bracket separately. The rule, that's how you pick the rule. So now, what is V? We said V is volume. So that means the dimension of B will be equal to, we already know that volume is length times width times height. And we have already know that length is L, width is a kind of length, height is a kind of length, so in the first video of dimension. So that means everything is L raised to power 3. That means the dimension of B is equal to dimension of volume before we can add, and that is L raised to power 3. That means we have solved for B just like that. So that is dimension of B. Now what of the dimension of A? Now to find the dimension of A, that is also easy. So you should know that dimension of A, you need to consider this bracket, that is P minus A over V square. Now for us to subtract these two quantities, dimension of A over V square must be equal to the dimension of P. Dimension of this one must be equal to the dimension of P. That means P is pressure in our case, and V is velocity, and V is volume is given. Check the question again. That means this will be A over L raised to power 3. You know we have found dimension of volume before, and that is for B. That is L raised to power 3. Down, and everything will be raised to power 2. V square. Only V is L raised to power 3. So everything will be raised to power 2. So that means dimension of pressure now is equals to, we found pressure before, but pressure is force. Let's do it separate. Pressure is force over area, and force is ml square, ml t raised to power minus 2 divided by area L square, so that L will cancel out. So dimension of pressure now will be ml raised to power minus 1. You can do that, work that out yourself, or you check the previous video. So dimension of pressure now is ml raised to power minus 1, then t raised to power minus 2. So that is dimension of pressure. So that means dimension of this one, A over V square, must be equal dimension of pressure. So we have A over L raised to power 6, because we multiply 3 times 2, 6, is equals to ml raised to power minus 1, t raised to power minus 2. This is over 1. So A is cross multiply. That is ml raised to power minus 1, t raised to power minus 2 times L raised to power 6. So now dimension of A will be equals to, now you have L raised to power minus 1 times L raised to power 6. Law of indices, minus 1 plus 6. That is L raised to power 5. So we have ml raised to power 5, t raised to power 2. That means the dimension of A is ml raised to power 5, t raised to power 2. You know that m is power 1. That means A, we have 1 dimension in m, 5 dimension in length, and minus 2 dimension in time, 0 dimension in current, blah blah. So that is how we can find dimension of A and B. It's clear now. Dimension of B will be equal to dimension of volume. Dimension of A over V square will be equal to dimension of pressure. So that's what we use to find A and B. Hope that is clear. Then let's move on to another aspects. So another aspect to consider here is let's call that rule number 2. Rule 1 is that the same quantity can only be added or subtracted if they have the same dimension. So that means rule number 2. Let's talk about sign here. Consider consider a term. Consider a term sine theta. So we already know that theta is dimensionless. Meter is dimensionless because we have already said that theta is arc over radius, and arc is a kind of length, radius is a kind of length, so that means theta is 1. We've done that in video 1 of dimension. You can check that again. So that means theta is dimensionless. Yeah, so if we have sine theta, and sine theta is also dimensionless. That means as theta is dimensionless, sine theta is also dimensionless. You know that sine theta is opposite over hypotenuse. And if you have anything, let's break down now. If I have here to be 4 meter, here to be 5 meter, and here to be 3 meter, you know they are all in meter. That means if here is theta, sine theta will be equals to opposite. This is my opposite. If you look at the units, there is meter over hypotenuse. The unit there is also meter. Do you know that is a kind of length over length? That will be 1. That means sine theta will also be 1. That means sine theta is also dimensionless. That means in this case there are two things that are dimensionless. Number 1, theta is dimensionless. Also sine theta is also dimensionless. So theta is dimensionless. Sine theta complete is also dimensionless, with what I show in the triangle now. So whatever comes in sine, in short, sine anything, as in if anything should come inside, is dimensionless. And the entire sine, including what is inside, is also dimensionless. Please take note of that. Again, if anything should come in after sine, or after sine, like sine 4s now, that means if 4s should come in, that means 4s is dimensionless, meaning dimension of 4s will be 1. Also the whole sine 4s is also dimensionless. It will also be 1. That's what we are trying to say. So if anything should come in after sine, that means the stuff inside is dimensionless. The whole is also dimensionless. Now the same application, the same thing is applicable to cos, tan, the same way. Meaning if I have cos, if anything should follow cos, that means everything inside this place is dimensionless. Then the whole cos everything is also dimensionless, like that. Now if it is tan also, if anything should come in, what is inside the bracket, anything inside the bracket is dimensionless. The whole tan is also dimensionless. Now if it is a number followed by anything, anything that follows the number is also dimensionless. The whole number or expression is also dimensionless. Now even though it is e raised to power, if anything should come in, e raised to power anything, or e anything that come inside the brackets is dimensionless. The whole expression is also dimensionless. Again, if we have log base e, anything inside that follows there is dimensionless. Anything inside here is dimensionless, the whole is also dimensionless. Now take note of all this. We are going to use them in example, but to understand better. And you know that log base e is also the same thing as ln. So if you have ln, anything inside the ln is dimensionless. All the whole ln is also dimensionless. So that means if I have ln, anything inside is dimensionless. The whole, everything is also dimensionless. Now let's see example on this row number 2. So let's solve questions. Yeah. So example 3. So example 3. Given that alpha is equals to f over v square sine beta t, where v is velocity, f is force, and t is time. Find the dimension of alpha and beta. So find the dimension of alpha and beta. Now to find the dimension of alpha and beta is easy. So let's say, let me clear this. Now in the question we have sine, do you see now that we have trig? Yeah, sine beta t. So if I consider that part, sine beta t, like this. Now what do we say? Because that's what we'll be picking out in any dimension, as in any question related to all these features. So you have all the rules already. You should know if you have sine, anything inside the sine is dimensionless. The whole sine also is dimensionless, like that. So that means if I consider sine now, so everything inside this bracket is dimensionless. It means dimension of beta t is equals to 1, meaning it's dimensionless. So that is the meaning. Dimension of beta t is 1. Also, the whole dimension here, everything sine, anything inside is also 1. But because it's beta, I want to find here, I'm using the techniques that dimension of everything inside sine is 1. That means it's dimensionless. That's the meaning. So meaning it is m raised to power 0 t raised to power 0, current, temperature, everything is raised to power 0 in that manner. So now it's beta t is equals to 1. Now what is beta? Beta is 1 over t. So that means dimension of beta is equals to 1 over t. You know t is time. So that means, and what is 1 over t? So beta is equals to t raised to power minus 1. That means the dimension of beta is t raised to power minus 1. We use the techniques that everything inside the sine must be dimensionless. That means it's equals to 1. If you say something is dimensionless, let it equals to 1, meaning it does not have dimension. So that is the answer for beta. Now let us find alpha. To find alpha, I will use the other techniques that alpha is equals to f over v square. Now we said everything in the brackets that follows sine is dimensionless. Also, the whole expression here is also dimensionless. That will be 1. So that is the theorem. So that means alpha, we've shown this, that sine theta will be dimensionless from that right angle triangle. We've shown that. So that means if you have everything there to be dimensionless, meaning all this will be 1. So phi is 1 now. Alpha is equals to f over v square. And what is f? F is given as force, while v is velocity. That means we know the dimension of force, ml t raised to power minus 2. divided by dimension of velocity. We found that in video 1 of dimension, that is lt raised to power minus 1 and everything raised to power 2, as in everything is raised to power 2. So these two will affect everything in the bracket. So that means alpha is equals to ml t raised to power minus 2 divided by L raised to power 2, meaning these two will multiply the power. Then T raised to power minus 2. These two will also multiply this power to affect everything. You notice this and this are equal. One L here, one L will go. So I will have M over L left. That means the dimension of alpha is ML raised to power minus 1. Meaning M over L is equals to M over 1 times 1 over L, and 1 over L is L raised to power minus 1. So we have this. So if you include time, that means ML raised to power minus 1 T raised to power 0, current is 0, temperature is 0, like that. So the answer to this question now is ML raised to power minus 1. So hope you get the techniques. That's it. If you have sine, cos, or tan, sine, anything inside is dimensionless, meaning is equals to 1. The whole expression is also dimensionless, is equals to 1. That's what we use in solving this question. Now, let's proceed. Let's see another question. So, let's see another question. Example 4. If alpha is equals to fv square over beta square log base e 2 pi beta over v square, where f is force and v is velocity, find the dimension of alpha and beta, and this is another beta. So what is the dimension of beta here in this question? Now we have principle and techniques already. So to find beta here, based on our techniques, let me remove this. So I've already explained that if you have log to base e, also everything inside the log is dimensionless. Also the whole log is dimensionless. That means in this case I can say alpha. So I've already said everything here is dimensionless. So if everything here is dimensionless, that means it would be 1. So do you know that I can easily say alpha is equals to fv square divided by beta square times 1. So why? Because all this is dimensionless. So I don't know alpha, I don't know the dimension of beta. So that is why I'll consider the brackets first. That is, everything in this bracket is dimensionless. So everything is in the bracket is dimensionless. That means 2 pi beta divided by v square is equals to 1. Don't forget, everything in the bracket is dimensionless. It will be equals to 1. After that, I will say all the expression here is also dimensionless. They will be equals to 1. Please understand the techniques. So that means if it is this, we already know that we can cross multiply to find beta. So that means we have 2 pi beta is equals to v square. That means beta is equals to v square over 2 pi, meaning you divide both sides by 2 pi so that you can find beta. So now if you don't get that part, 2 pi b is equals to v square. Divide both sides by 2 pi so that 2 pi will go. So pi is beta is v square divided by 2 pi. Now dimension of beta. Now we can say, what is v in the question? V is velocity. That means dimension for velocity is t raised to power lt raised to power minus 1 everything square. So there is square there. Then divided by 2 pi. Remember, 2 is a number, it will be dimensionless. Pi is also constant, is a dimensionless. We've talked about this in first video. So now that means beta, so if you see ordinary number or pi, is dimensionless. So now this will becomes L square t raised to power minus 2, because this is power 1. 2 times 1, 2, then 2 times minus 1, minus 2. So now this is the dimension for beta. Now what of alpha? So I'll use the other techniques that the whole expression is also dimensionless. That means I'll have alpha is equals to fv square divided by beta square. Everything will be 1 because all the whole expression will be dimensionless also. That will be 1. So that means in this case I'll say alpha is equals to fv square divided by beta square. So alpha is equals to, what is f in the question? Force. And dimension of force is ml t raised to power minus 2 times what of velocity? Lt raised to power minus 1, but everything is raised to power 2, divided by beta. We know our dimension for beta as L square t raised to power minus 2. This one, we found it just now. That's the first one. Go back to the video. So brackets, everything is square. The first part of the question we find beta, and this is the result. But that beta is raised to power 2. I have to square it also. So in this case, alpha is equals to ml t raised to power minus 2 times this 2 will affect L. It will also affect T. That is, this is 1 times 2, that will be 2. Then minus 1 times 2 again. Everything over this 2 will also affect this. That will be L raised to power 4 times T raised to power minus 4. These two will multiply the two powers like that. Now let's simplify further. Alpha is, which one can cancel out? Yeah, we have L squared here. It will cancel out this one. This will remain L squared because 2 of it will go. Now t raised to power minus 2 minus 2, it will be t raised to power minus 4 together. If you multiply, it will cancel out this one. So 1 L will go, 1 L will go. So everything that will remain is m over L. So dimension of alpha is ml raised to power minus 1. So that's the dimension of alpha. So we are true. So the next video will be uses of dimension. So uses of dimension is our next topic. Uses of dimension. So that will be the next video. Thank you.